Hi all. 12th class, 3rd chapter current electricity, 19th session. Last class we discussed about Wheatstone's bridge, and this class is about application of the Wheatstone's bridge. And one of the most important application of the Wheatstone's bridge is the meter bridge. What is a meter bridge and what is its use and how it is used? This is what we are going to learn now. What is a meter bridge? Meter bridge is an instrument used for measuring unknown resistance. Used for measuring unknown resistance. It can also be used to measure resistivity of a material. And it is using balanced Wheatstone's bridge condition. Balanced Wheatstone's bridge condition. It is using balanced Wheatstone's bridge condition. How? Let me draw the figure for a meter bridge. Then I will correlate it with Wheatstone's bridge. Actually, meter bridge consists of two L-shaped metallic strips and one horizontal metallic strip, which have got two gaps. Actually, it is placed on a wooden plank like that. It's fixed on a wooden plank, something like that. And it have got simply copper strips, which have got two, what we say, gaps. And here, at the 2 points, let it be between A and B, there is a uniform wire of same thickness, uniform wire. Simple metallic wire which have got a uniform thickness, whose thickness is same everywhere. And you will get one cell. You need a connection, disconnection, then you can apply a switch also, a key also. This is a cell. And the cell will enable current to flow through it, through the junction and all. So this is the lower part of the circuit. And at the two gaps, the left gap, we fix a unknown resistance whose value is to be found. At the left gap, you fix unknown, or you connect the unknown resistance whose value is to be found. And at the right gap, you connect a resistance box. A resistance box is a setup in which you can take out or you can take desired value of resistance. That value of resistance can be measured from the resistance box itself, or it will be indicated. The value of the resistance will be indicated in the resistance box itself. That you will see in your laboratory. It's an experiment, you are doing it in your syllabus. So it will be very interesting to understand the theory of it. This is what actually the basic circuitry. And connecting both the two, see, this is a strip means all the points are connected. This is a strip means this is connected to A and this is connected to B. So something like that, right? It's only a connection. The strip means it's only a connection. It's only a connection, that's all. Now, connecting these two, we have a galvanometer, instrument to measure current or presence of current, and a slidable contact known as jockey. It's a slidable contact. You can move the contact like this. Jockey. You can move the contact like this. You can slide the jockey over the wire. So if you connect it here, the connection will have this much length this side and the remaining length other side. Actually, this wire is of 1 meter long, and below there will be a 1 meter scale. There will be a 1 meter scale so that you can measure the length of the wire of required points. It's a 1 meter long wire, right? 1 meter means 100 centimeter long wire. Below there will be a scale. This is what actually circuit is. The circuit is over. This is galvanometer. Now what you have to do is connect this unknown resistance, non-resistance, whatever be the value of known resistance. Now switch on the circuit, current will start to flow. Move the jockey, and when you move the jockey, you will find that the galvanometer will have a scale like this. So this is 0 and this is plus 50 or something like that, minus 50, whatever it be. It will be showing a reading in one direction. When you connect the circuit, it will be showing one direction. And when you move the jockey through the wire, the reading will start to decrease. Decreasing means coming towards the center. The reading will start to decrease. And at a particular point, when the galvanometer shows 0 reading, you have to stop it. You should not move jockey, and you should be very careful. And you have to make something like a pen marking or a marking using pencils over the board, which is all this setup will be on a wooden board. You have to mark that. You have to mark very carefully. You have to mark the position of the jockey, and you should measure the length, and this be the length L. So naturally this is 100 centimeter long. So if it is L, this will be 100 minus L, right? Okay. Now I told you one thing. This is a uniform wire, right? And wire have got its own resistance. Just for the sake of understanding, let me say small r is the resistance per unit length of wire, right? Small r is the resistance per unit length of wire. Resistance per centimeter of wire means each 1 centimeter will have a resistance of small r. That's it. That's all. Now how can you connect it? If I say it is A, B, and suppose I name this point C and D, this point as D. Let me redraw it. Right? I'm going to redraw it. So what we got, the condition is balanced Wheatstone's bridge is, balanced galvanometer is there, or zero deflecting galvanometer is there, and there is a length of one side and 100 minus length on the other side. This is what is happening. And let me redraw it, right? And I will compare it with the Wheatstone's bridge. Now let me connect these 2 points, A and B. Is it okay? A and B. And between A and B, there is a resistance. Sorry, there is a cell. Okay, that's cool. Between A and B, there is a cell connected with a key, whatever it be. Now, between A and B, let's draw it a bit more height. This is point B and this is point A. Okay. Now, what are the other resistors? At the point C, if I make it like C and this point as D. Okay. And between A and C, there is an unknown resistance X, isn't it? Between A and C, there is an unknown resistance X. Yeah. This is unknown resistance X. And between C and B, there is the known resistance R. Yeah, between C and B, there is known resistance R. Correct. And between A and D, there is a wire. That's it. And the wire is a resistor itself. Between A and D, there is a wire. And that wire have got a resistance LR. Why? Because I told you small r is the resistance per centimeter. And there is L centimeter one side. So the resistance of that side will be LR. Now you can imagine what will be the resistance of the other side between B and D. Between B and D, it will be 100 minus LR, isn't it? And I forgot to draw one thing between C and D. Between C and D, there is a galvanometer. And the galvanometer now shows zero deflection. Galvanometer now shows zero deflection means what? Ig equal to 0. There is no galvanometer current. Means what? It's a Wheatstone's bridge. And the Wheatstone's bridge is balanced also. And what is the condition for balancing the Wheatstone's bridge? P by Q equal to R by S. Just like that, here it will be X by R equal to LR by 100 minus L into R. Am I right? So this smaller cancelled. X is equal to R into L divided by 100 minus L. This unknown resistance X is equal to the known resistance R into measured length divided by 100 minus L. So we measured the value of unknown resistance. So that's the first application to measure the unknown resistance. Next is to find the resistivity. Suppose instead of this resistance, we have a wire whose resistivity is to be found. Okay. Suppose we have a wire whose resistivity is to be found. You take this wire and for this wire you have to find the unknown resistance first. So that will be X. Now this wire is X. The resistance is X. And what is that X equal to? X equal to the resistance of the wire, and that is equal to rho L by A. Got it? You find the same thing, you find the resistance of the wire you find now, and that X is equal to rho L by A. Using non-resistance into L divided by 100 minus L, you can measure what X is. Now suppose this is the wire, right? Using a scale you can measure, or using more accurate devices you can measure the length, and it will have a circular cross section. Using a screw gauge you can measure the diameter, and the area will be equal to pi r square. So X is equal to rho L divided by pi d square by 4. Because screw gauge will be giving directly diameter, it will be pi d square by 4. Means X is equal to rho L into 4 by pi d square. So if you want to measure the resistivity, it will be X pi d square divided by 4L. That's all. You can measure the resistivity of that unknown material. So it's simply an application of Wheatstone's bridge. Isn't it? Very simple to understand. That's all. Thank you.